Okay, so I'm here today to talk about the future of the transportation industry, but I feel like to start off with, we need a little bit of background on where we're at with transportation today. If you watch the headlines at all, you may have seen that things have been a little crazy over the last few years. And really, it all started about 5 years ago when the world got serious about eliminating CO2 emissions. And in transportation, really the expedient solution is to eliminate the internal combustion engine. And so, despite some initial pushback, we've seen over the last 5 years, most of the major OEMs get in line with this goal and have laid out plans to phase out engines, many of them starting in 2035. And so with that, the electric revolution was born. We saw the meteoric rise of companies like Tesla and Rivian that made electric vehicles attractive and popular. And then we saw this great ballooning of offering of vehicles, from everything from small passenger cars to trucks and pickups to large commercial vehicles and semi-trucks. And so it really started to look like this solution was to electrify everything. But now we fast forward 5 years to the present, and if you watch the headlines today, you might be thinking, what's going on in the transportation industry? We're seeing dramatic reversals of a lot of not only the policies, but also the product strategies for many of these companies, particularly related to electric vehicles and the rollout of that technology. And so it's starting to look like this electric revolution is dying about as fast as it began. And to understand where this electric revolution went off the rails, we kind of have to expand our understanding of sustainability a little bit. So we tend to think of sustainability in terms of the environment and the impacts that our technologies and our actions have on the environment. But in reality, there are also factors of quality of life and economics that come into play, and a whole interplay of other competing interests in between. And it's really at the center and the intersection of all of these competing interests that we find truly sustainable solutions. So if we look at the EV revolution in particular, one of the major problems with this revolution was this intense focus on tailpipe emissions. It's true that if you look at densely populated areas, eliminating tailpipe emissions does have a dramatic effect on local air quality. But that approach often neglects some of the other adverse effects that we see in developing these vehicles and a lot of the embedded CO2 that goes into just building the vehicles to begin with. And then we add to that high development costs and some inconveniences like long charging times and range anxiety. We've got very high vehicle cost and limited resource availability, and all of that comes together to make electric vehicles unsustainable for the majority of consumers. So here we have an option. We can do one of two things. We can either continue to try to balance this out by throwing more money at the economic side of things. We can try PR campaigns to try to convince people to lower their expectations on the quality of life, or we can take a step back and look for a more sustainable solution. But of course, the last thing that we want to do is replace one unsustainable solution with another equally unsustainable solution. And so as we're looking for these alternative technologies, we have to follow this more holistic approach to find that balanced and sustainable solution. So from an environmental standpoint, we absolutely cannot give up on the zero CO2 goal. We also want to minimize any other emissions and make as little impact on the environment as possible. But from an economic standpoint, really what we want to do is try to leverage existing technologies as much as possible, and that's going to help with the economics and the growth of these various technologies. And so when we look at this from the standpoint of our customers, who are the major vehicle manufacturers, they're really facing an existential crisis in that they have massive amounts of capital invested both mainly in engines, but that's both in the technology development, but also in this huge manufacturing footprint that they've got across the globe. And what we're seeing is that many of them are struggling to reinvent themselves as pure electric vehicle companies. So as an alternative, what we're looking to do is find ways to eliminate the CO2 from the vehicle without eliminating the engine itself. And it turns out that we can do that by just removing the carbon from the fuel. When we think about, back to chemistry 101, most of the fuels that we use today are just long chains of carbon with attachments of hydrogen molecules. And so when we take out that carbon, we're left with pure hydrogen. And in its base state, hydrogen prefers to be a diatomic molecule, or H2, you may remember. With this goal of leveraging the existing technology and burning H2 or hydrogen in these existing fuels, we launched the H2ICE consortium. So that stands for Hydrogen in Internal Combustion Engines. And then finally, from a quality of life standpoint, our customers, who are all of you, are relatively resistant to change. At the end of the day, all of us want some kind of assurance that the technologies that are being offered are going to give us similar performance and reliability from what we're used to in the status quo. And the best way for us to be able to do that is through large-scale technology demonstrations. And so we started with this premise of we want to use hydrogen in internal combustion engines, and we wanted to make the centerpiece of this a big technology demonstration. But we were still left with the question of which vehicle and which technology would really have the greatest impact. So ultimately, where we landed was kind of right in the middle of the transportation space with the Class 8 long-haul heavy-duty truck. And that is both because of the technology challenges that this presents, but also because these vehicles represent a very large percentage of the total CO2 that is produced in the transportation industry. If we look at this space, so the smaller vehicles, we see technologies like mild electrification and hybridization as having more potential for impact and as bridge technologies to get us through until the economics of the batteries works out a little bit better. In the larger space, we're really looking at other low carbon liquid fuels to give us the energy density that we need in order to get the job done in those spaces. But right in the middle is kind of the Goldilocks conditions for hydrogen, where we can carry just enough hydrogen on the vehicle to do all of the work that we need to do in a single day without dramatically increasing the size or the weight of the overall vehicle. And so that's where we landed for our technology demonstration target. And from there, the objectives of the consortium were pretty straightforward. We started with a very aggressive 18-month timeline. And the reason for that was that we wanted to align very directly with the timeline that the EPA had set out for establishing their future greenhouse gas regulations. And we wanted this vehicle to be out there in the public as those rules were coming together. And as we talked about before, we wanted to utilize as much existing internal combustion engine technology as possible to enhance the economics of this situation. And also as a foundation for all of our consortia here at the Institute, we wanted to foster a pre-competitive and collaborative environment. As you can see on the vehicle here, we had a lot of participants in the program, and many of them are direct competitors. And so there could be the temptation to jockey to make sure that their individual components were highlighted in this demonstration. And so we needed to foster this collaboration and ensure that we were focused on the technology and providing the solutions rather than just demonstrating any individual part or component. And so the results of the consortium, you saw the truck today, and if you want to look at it closer, we'll have it up in the parking lot by the cafeteria. But we were able to start with this pretty old and outdated high mileage vehicle get it all dressed up and cleaned up and ready for the princess that it is today. We started with a natural gas freight engine that eventually we were able to demonstrate the same equivalent torque, power, and engine response as the diesel engine, and then get it all dressed up and pretty and operational for its debut in May last year. Also, along the way, we were able to demonstrate some of the lowest emissions that have ever been seen from a heavy-duty vehicle. And more importantly, we established the Institute as a leader in H2ICE research and development. And from that platform, we're continuing to advance hydrogen combustion technology in several different ways. Starting with our research consortia, we're continuing in that same vein and building on the success of the previous consortium. We're getting ready to launch the second consortium, or the second phase of the consortium now, focused more on bringing these technologies to market and breaking down any remaining barriers to getting these technologies out there. And that really means supporting the entire product cycle, from the combustion modeling and individual component testing. We've got great platforms to be able to do that now, to test these components in situ. We're building up complete combustion systems and engines for other continued demonstrations. And then finally, we're upgrading our emissions certification laboratories with the right equipment and test protocols to be able to certify these engines when they do come to market. So now we come back to the million, maybe $1 trillion question: is H2ICE really sustainable? And to answer that question, we need to come back to our original Venn diagram. So from the environmental standpoint, we've eliminated 99.9% of all CO2 from the engine, and that's with existing technologies and components that are available today. And we've also demonstrated near zero emissions in just about every other pollutant that you can measure. From a quality of life standpoint, we've demonstrated a familiar technology and a lowest overall vehicle cost, and that comes mainly from leveraging the economics and allowing the existing engine and vehicle manufacturers to carry over a significant amount of technology from their existing vehicles. So if you were to get out your magic 8-ball and ask it, is this a sustainable solution? It seems like all signs point to yes, but not so fast. So the last time you pulled up to a pump to fill up your car with either diesel or gasoline, how many of you saw an option to purchase hydrogen at the pump? And probably nobody, because really, in reality, there are about 30 existing hydrogen fueling stations, and they're all in Southern California. And if you were to go to one of those stations, any guesses how much you'd pay for about a gallon equivalent of hydrogen fuel? It's about $36. So clearly not a sustainable solution there. So we have some work to do on the hydrogen infrastructure, some of the hydrogen production side of things, and really that all comes down to supporting the hydrogen economy. And when we talk about the hydrogen economy, there are really 3 pillars of this economy that we're talking about. And it's the sustainable production of hydrogen, safe and efficient distribution, and healthy consumption and demand for hydrogen. And all of this is supported by an infrastructure that looks very similar to the hydrocarbon-based infrastructure that we see today. But the problem is that infrastructure that we know and love today took about 100 years to develop, and we can't wait that long for all of these technologies to mature if we're going to meet our CO2 targets. And so, as Adam talked about, we focus on kind of collaborating across the Institute, and that's what we're doing in the hydrogen space. Our goal is to work across the entire hydrogen economy in ways that we can help to grow and accelerate the growth of this hydrogen economy while keeping things balanced. And so we're doing things with our chemistry division, helping to support the sustainable production of green CO2. We have our state-of-the-art hydrogen storage facility here, where we can not only supply the hydrogen to our test facilities, but also understand the ins and outs and challenges of storage and distribution of hydrogen. And in parallel with these other consortia that we're running, our mechanical engineering division is getting ready to launch another consortium that's tasked with looking at all the flow components that will help to make these hydrogen refueling stations economical and reliable. And of course, as we've talked about today, we're continuing to fuel the healthy demand for hydrogen by providing new and novel solutions for hydrogen consumption, both with internal combustion engines and with fuel cell electric vehicles. And so with all of this, we're laying the foundation of what we think will help sustain the Institute and provide a bright future for the Institute, but also provide a sustainable solution for the transportation industry.
All right, thank you so much, Ryan.